Alright, we're going to solve example 3 here, which is variation on example 3 in your book in section 5.2. And again, it's another solve the system of equations by substitution, but what's different this time is that our equations have fractional coefficients. So we have all these fractions, and basically the only thing different that we're going to do is we're going to get rid of the fractions and then reduce it to integer coefficients, which we've solved the last 2 times before. And how do we do that? Well, the trick is the lowest common denominator. We have to find the lowest common denominator of all of the denominators, say in equation 1. So what is the lowest common denominator of 12, 4, and 2? And the answer is 12. Now, lowest common denominator is also called lowest common multiple, right? Because that's what it is. 12 is a multiple of 2 because 2 times 6 is 12. 12 is a multiple of 4 because 4 times 3 is 12. 12 is a multiple of 12 because 12 times 1 is 12. And it turns out 12 is the lowest of these. We could use any common multiple and this will work, but the lowest common multiple ensures that we don't have to worry about factoring out common factors later. So anyway, let's number these: equation 1, equation 2, and let's start with equation 1. So we have 1/12 x plus 1/4 y equals 3/2. So what are we going to do? We are going to multiply both sides by our least common denominator, which is 12. Alright, so we're going to break down the parentheses by distributing the 12 over what is inside the parentheses. 12 times 1 is 12, so I have 12 over 12x plus 12 times 1 is 1, so that's going to be 12 over 4y equals, 2 goes into 2 once, 2 goes into 12 6 times. Of course, that's the way we planned it. 6 times 3 is 18. Now we're going to get rid of these guys. That's just 1, right? Anything divided by itself is 1. 4 goes into 4 once. 4 goes into 12 3 times. So we're left with x plus 3y equals 18. Hooray! No more fractions. This is our brand new equivalent equation 1. Alright, it worked once, let's see if it'll work twice. It should, of course. So now the question for equation number 2, what's the lowest common denominator for the numbers 5 and 2? And the answer is 10. Alright, 2 times 5 is 10, 5 times 2 is 10. Alright, so we do it again. We have the equation 2/5 x minus 1/2 y equals minus 3. We're going to multiply both of these by 10. Alright, so we break down the parentheses by distribution, so that's going to be 10 times 2 over 5x equals 10 times 1 over 2. That's a minus. 10 over 2y. Minus 3 times 10 is minus 30. And now comes the fun part where we get rid of all the fractions. 5 goes into 5 once. 5 goes into 10 twice. 2 times 2 is 4. So all leaves us with 4x. 2 goes into 2 once. 2 goes into 10 5 times. So that's minus 5y equals minus 30. So this is our brand new equation 2. Again, no fractions. Hooray! Alright, so now we just do the 5 steps as we did before. Step number 1, solve one of the equations for one of the variables. If possible, solve for a variable that has a coefficient of 1 or minus 1. Well, that's going to be this guy right here. Okay, so step number 1, equation number 1. and we're going to solve for x plus, we solve for x, and the equation is x plus 3y equals 18. Solving for x just means getting this guy to go over here. Easy to do. Subtract 3y, subtract 3y. I get x, this goes away, equals minus 3y, minus 3y plus 18. So we did this. We solved for one of the equations. We solved one of the equations for one of the variables. We solved for x. Now we're going to substitute this and substitute the expression found in step 1 into the other equation. So step 2 deals with the other equation. Well, the equation we used was 1, so the other equation must be equation 2. Equation 2, we are going to substitute the expression. This is the expression, right? We're going to substitute that into equation 2. What's equation 2? Well, it's 4 times x, but we're going to make room for the substitution by putting a parenthesis in place of the x. Minus 5y equals minus 30. And x, that's this guy, we're going to put in its equivalent, and we get minus 3y plus 18. Again, we break down the parentheses by distribution. 4 times minus 3 is minus 12y. 4 times 18, well, that's plus. 4 times 8 is 32. Hold to carry the 2. 1 times 4 is 4, plus 3 is 7. So that's 72. Minus 5y equals minus 30. All right. Let's just check. Do we finish that? Substitute. Yeah, blah, 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 blah. The equation should give you one variable. And the one variable I have is y. So we're done with step number 2. So now we move on to step number 3. What is step number 3? Step number 3. Step number 3, this guy. Solve the equation you obtained in step number 2. Okay, we can do that. We're going to combine like terms. That's minus 12y minus 5y. That's minus 17y plus 72 equals minus 30. Subtract 72 from both sides. Minus 72. That, of course, disappears. I have minus 17y equals 2 plus 0 is 2. 7 plus 3 is 10. And we have 2 minus signs, so that's going to be minus. Alrighty, now we want to get rid of this minus 17, so we're going to divide both sides by minus 17. Let's get our handy dandy calculator out here. We have 102 divided by 17. That's going to equal 6. Okay, so that goes, this goes away. That becomes just y equals 6. Alright, so we solve that equation. We're done with step 3. Step 4. Substitute the value found in step 3 into either of the equations to obtain the value of the other variable. Alright, we can do that. Step 4. Do that over here. So we can pick the equation that we want to use. Well, let's see. We can do 2 or we can do 1. I'm going to pick 1 simply because 1 has lower coefficients on the left-hand side, which means I deal with simpler arithmetic. And I like to keep things simple. It's an old engineering principle, KISS principle. Keep it simple, stupid. Okay, so step 4. I want to substitute the value. Okay, what was the value again? The value is y equals 6. And I'm going to substitute that into equation 1. So I get x, this is equation 1, x plus 3 times oops, it should be y, but let me put the 6 in there instead, equals 18. So that's x plus 3 times 6 is 18 equals 18. Subtract 18 from both sides, and this disappears. I get x equals 18 from 18 is still 0, so I get 0. So I have an answer of x equals 0, y equals 6. Am I done? No. I finished step 4. Now I got to do step 5. Check the values in each of the original equations and write the solution as an ordered pair. Okay, so I have to check. This is step number 5. Check. Alright, so what's equation 1? X plus 3y equals 18. X plus 3y equals 18. And when I plug it in, is that going to be true? Well, x is 0, right? That's this guy. And y is 6, that guy. So we plug that in. 0, well, 0 goes away. 3 times 6 is 18. Yes, 18 equals 18. So this is true. So we know that our solution at least satisfies equation 1, but it also has to satisfy equation 2. What's equation 2? Well, let's look up here. Equation 2. 4x minus 5y equals minus 30. 4x minus 5y, does that equal minus 30 when I plug in my answers? Again, x is 0, so I put in a 0. Y is 6. Put in a 6. 4 times 0 is 0. That goes away. Minus 5 times 6 is 30. And minus 30 equals minus 30. So this is true. And of course, the last part of it was to write it as an ordered pair. And the ordered pair is 0, 6 is a solution. Not a solution, it is the solution. There is only one. If you were to plot these two lines, you would see that they intersect at the point 0, 6. Alright, by now you should know the drill. I've done example 3. You should try to do example 3 with slightly different numbers, the numbers that are in the book. If you find that you can't do example 3, you may want to look at Ms. Messerschmidt and the detailed explanation of the solution that she gives. She and I may not always do it exactly the same way, but that just shows you there's many ways to skin a cat. Anyway, good luck.